Hi, one. Okay, we'll start in a while, and we'll start with the server technologies because one needs to understand what is the role of a server when we're talking about infra, and particularly from the internet point of view, and what kind of servers would be required for the deployment of not only 5G, 6G, but the other generative stuff which has been developed over the years. And we are going back to a lot of basic understanding, and I will delve into the I might just take up few of the pattern applications to explain the whole process. So we'll wait for a few more minutes and then we'll start. So particularly our discussion would be around the okay. So we are going to talk about telecom servers. We are going to touch base on the basics of telecom servers. So I'm just setting up the stage. Stage here is basically the UIs here. So yeah. Okay. I mean, I'm particularly going to. I'm working on a couple of devices right now, so you might be seeing me on different screens, maybe at different angles. Okay, so we'll just start in a while. So I'm going to start with the complex stuff today, and then we'll filter down to. I don't know how many people will be able to resonate because the patenting language is very different. Um, yeah, and what are we going to discuss? Just give me a moment. So you're going to discuss this particular pattern application, which is identify firewall with context information tracking. So you're going to talk about the hardware sector first because hardware plays a pivotal role in. I'd rather say because I'm trying to use the simple words so that more people are able to resonate. Because in the patenting language, we as patent drafters, the frameworks are written in a very different format. But I'll be talking about most of the China based devices, most of the hardware based out in China, it's on the C band. And why C band is good, we'll talk about the C band first and then I'll talk about the other aspects. So, first, we are going to talk about why C band has a purpose and why it is deployed. Um, and why C band is a better alternative for the generative technologies, particularly in the 5G. Actually, I'm just talking about the Taiwan cities right now because there's a lot of disconnect in terms of the understanding of intellectual property rights, and we have to go in deep dive and understand how this is cropping up in terms of the players who are the major players and who why the infra in the sector needs a lot of attention from the government because incentives has to be given by the government and it has to be on the long term basis. It cannot be like today if X government is there, this incentive is based here. If the government changes, then also it should not impact the communication sector. And this is basically why it is important is so many companies are entering India in terms of the talent pool India has. It is, I mean, it's a lot more than any other country. Of course, in comparison to China, um, I'm not the right person to comment on the talent quotient of these two countries because I have been working with a lot of people globally, 140 plus countries, rightly starting from Ecuador to San Marino to whatnot. So, first of all, we'll talk about the C band, which is in the spectrum, the coverage and the capacity. It is a preferred choice for 5G deployment, and a lot of research is done by China in this regard. And why C-band has a lot of value, particularly for tier 2 and tier 3 cities in the rural and the suburban areas, is its high power limit, its minimal coordination requirement, and high licensing area makes it more cost effective because we have to see the coverage. We cannot be working in silos and say, hey, this will work because of XYZ reasons. And the problem statement for the longest time, if I have to talk about India and if I see the landscape of the government from 2006 till 2025, I mean, the government people were not even talking. You go to any of these conferences which are happening globally, the government people who are supposed to attend the conference are not even on the table. So what is the use of sending, because this is taxpayers money. I mean, if the government people are supposed to, if they are going and they are being representing the country, like private players like us, we sit in the conference, we understand everything, we have those I would say the one-to-one conversation, but the decision making is with the government because the government needs to give those incentives. The government needs to understand the bigger landscape, and all these people who are actually visiting these countries, they should be reporting back to the government in a regard where a proper reporting has to be done. It cannot be like just you go somewhere and you do it and you just come back. That doesn't happen. So basically, the C band is 3.5 gigahertz range, which is widely adopted as a principal 5G launch pad. And it's a, obviously it's a band, but the launch pad is 5G. This has driven by the wider ecosystem, increased diverse and diversity and the competition. The global adoption of C band ensures better interoperability because a lot of technologies which have been developed understand one thing: there's always been a term called as evergreening. So this word evergreening has been a very common word in the pharmaceutical sector. However, to combat all this, in my world, because I've been working in intellectual property for so long and I've worked on, small microchips to the basic technology of whatever people can think of. The point of contention here is there's something called as essential patents. Essential patents or the essential technology is one aspect. The other very important aspect is a trade secret. The trade secret is basically or the technical know-how, and there's a difference between the word technical know-how and know-how. So the basic understanding here is to appreciate that this know-how and technical know-how, even the patent doesn't, it is not doing justice. I mean, how do you expect a human, I think you should not even talk about humans in terms of even we cannot give this to an AI because the detailed description itself of a patent application, I have seen patent application. Oh my gosh. I mean, that time I never used to understand. I mean, somebody is filing patent claims, 300, 400 patent claims. I was like, why are they filing 400 patent claims? And now I realize what is the story behind it. And the application itself is like 300, 400 pages. Can you believe that those kind of applications were written? And now if you see, it's like, I mean, 10, 15 pages, 20 pages, 30 pages max, and what is written doesn't even hold good. So the use case study for C band is in the enhanced broadband. So that is EMBB. Then we have FWA, which is fixed wireless access. And then we have data incentive intensive applications such as video streaming, IoT devices. IoT is Internet of Things. So in Internet of Things, what happens is loads and loads of sensors are deployed, and those sensors are supposed to sense and take that data parameter, and then it is fed to these machine learning algorithms. And again, machine learning algorithms should be proprietary. Otherwise, something which is free source, I mean, which is not proprietary, it can, or it will be at some point of time, intruded by external factors. And the C-band auction generated higher revenue giga per megahertz, and as compared to other bands like CBRS, indicating higher value for 5G services. So yes, I worked a lot on the MIMO and MIMO antennas, and these technologies enhance the network performance, and they actually provide higher data throughput, making C-band very flexible for the advanced 5G applications. So for every operator, the C-band is providing 80 to 100 megahertz, which maximizes the network performance by minimizing the consumer cost. And particularly, this spectrum lies between 3.4 to 4.2 gigahertz, offers a balance between the coverage and the capacity. It makes ideal, and unlike, so there's something called as high band frequencies. It provides ultra fast speed but has limited coverage. But C band delivers high speeds over long distances. So ZTE has emerged as a strong player in the telecom sector, particularly in China. In 2022 itself, it ranked first in server shipments in China telecom sector with almost 1,75,000 units. They offer diverse product range. It has full range of servers and storage products, including general servers, GPU servers, and then we have liquid cooling servers. See, the downtime of any server would be costly. So what is important here is to go carbon negative. And to go carbon negative, a lot of technologies, which is more of a trade secret, even the patent is filed, it doesn't mean that, if you have a patent, you'll be able to deploy it. That doesn't work like that. There's a lot of technical know-how in deployment of any kind of technology. So we are going to talk about this particular patent application. Give me a moment. Da, da, da. We are going to talk about this US patent application number bearing a number 2024 0031334, which is assigned to VMware LLC, having a proprietary date that is the first filing date, 19th day of July 2022. So, Okay, so basically, this pattern application is identity firewall with context information tracking. And what is it doing? So basically, this particular application is detecting a connection which is established with a virtualized computing instance. It is a critical step because it triggers the subsequent processes of tracking and evaluating that particular connection. So it's basically it has a trigger here. And once the connection is detected, the system is able to track associated with the connection. What we have is a first identity information. This is associated with prior connection between the client device and a second computer device. So where is the first computer device? Okay, it talks about second computer device. It facilitates the establishment of historical context of the client interaction. So basically, it is somehow uh, reviewing the data between the client device, which can be a handle device, it can be computing device, it can be any of the devices. And there's a second identity information. So they have divided the identification information. It's basically, see, for example, there's an X person. The X person will have a first identity information, and there's a second identity information. It provides real-time context about the ongoing interaction. The system obtains a first identifiable policy associated with the blah blah blah. This policy defines the rules and criteria for allowing and blocking traffic based on the identity. Okay, great. What are they trying to claim? It's not a complex innovation per se, but I'm just going through. So rather than using the word data, or they have been using this word here. Um, okay, rather than using the word data, yeah, they are using the word first identity information. So information itself is data. I just want to see the flow. Okay, they have this edge stuff here. So basically, based on the interaction and the parameters which are there, it's like doing the same thing but singing a different song. So the point I'm trying to make here is most of the pattern application and most of the landscape in the telecom sector is like doing the same thing but singing a same different song. That means using different words and just twisting it to reach a similar product. So that is how it is done. And the rest part, I have the data set with me. Probably I'll push some articles in this, and if I like some particular application, because as I said, I was just going through, I just browsed through almost 100 applications, and most of the applications are just singing the same song. It is just the wording which is different, but the outcome is the same. And it's not that one particular patent is solving another patent application. So yeah, so I think we are good for now. If I have to conclude, the conclusion would be a lot of infra is needed for the whole aspect of this 5G and everything, and the government has to be very proactive in providing that kind of backing to the telcos, which is very important for them to survive. Thank you for watching out the video. Have a great day ahead.